Hello. We'll be looking at finding the length of an interval or the distance between 2 points. If you remember, interval means any part of a straight line which has got two ends. For example, here AB is an example of an interval. So part of a line, the difference is line goes forever, but an interval is only part of a line which has two ends, start and end. Here, AB is an example of an interval. Now we want to see how basically we can find the length of interval A, B if we know the coordinates of A and the coordinates of B. So if I have been given the coordinates of the ends of an interval, how I can find how long that interval is going to be. As you can see, like here, each one of this is 1 unit, like 1, 2, 3, 4. And I know A has the coordinates of, for example, 2 and 7, and B has a coordinate of 6 for x and 4 for y. So the coordinates of B is 6 for x and 4 for y. So I know this set of information. I want to see AB will be how long as compared to this unit. So this is 1 unit. So how many of these units of these divisions will fit into AB. All right. One thing you got to be remembering is this relationship. A squared plus B squared equal to C squared. Or C squared is equal to A squared plus B squared. You guessed it right. This is Pythagoras Theorem. So we got to remember Pythagoras Theorem. Why is that? Because if I want to find the length of AB, I can make up a right angle triangle like this, which includes AB. So we have this right angle triangle. So I added this side and this side to that to turn it into a right angle triangle. Then if I want to find AB, which is in this case my C is the largest side or the hypotenuse. So C is the longest one, and in this case it is the one we want to find. And these are the shorter sides, A and B. It doesn't matter which one you call A, which one you call B. So for instance, A is the length of this and B is the length of this. Then C will be the length of this, the length we want to find. All right, but why is that helpful? Because these short sides are easy to work out. These short sides. Why? From here, we can straight away see that this short side is 1 division, 2 division, 3 division. You got 1, 2, 3. So the shorter side is 3 divisions, and the other short side is 1 division, 2 division, 3 division, and 4 division. So straight away, I can see that my short side, one of them is 3 units, the other one is 4 units. So A here is 3 and B here is 4. It doesn't matter if you call A 4 and B 3, the order doesn't matter. Anyhow, then if I want to use this, I can say AB squared, because AB is the longest side, or C here, equal to the shorter sides squared and added. One short side was 3, and the other one was 4. So 4 squared plus 3 squared, or 3 squared plus 4 squared. And if you do work that out, 4 squared is 16 and 3 squared is 9. Then we add them. So find the 3 squared first and then add them. So 4 squared 16, 3 squared 9. And that comes 16 plus 9, which is 25. So AB squared is 25. So you got to think of a number that when you're squaring it, because AB is a number that I've squared it, and I've got 25. That number must be 5, because 5 squared is 25. So we find AB. AB is 5 units. So 5 of these divisions can fit in this AB. So 2 things you got to remember. One is Pythagoras Theorem, and the other one is how to find the shorter sides, which is not a challenge, as I said. You can straight away see how much is your shorter sides, this one and this one. Even if they haven't given you, like you don't have the divisions here, but you know, for example, B has an x-coordinate of 6 and A has an x-coordinate of 2, you know that this length from here to 6, from 2 to 6, is 4, which is 6 take away 2. So then you need to subtract the x's of B and x's of A. So that becomes 6 take away 2 is 4. So you get that 4. And to get this, even if you cannot count here, because you don't have divisions given to you, again, look at the y of the 1 point, like in this case is 7, y of A, and y of B is 4. And this length, the other short length, is 3, which is actually 7 take away 4. So y of A take away y of B. That gives you 3. Yeah, that is for the first question. Let's look at the example 1. Here they are giving us 2 points, the point K with the coordinates of 3 and 7, so that's x, that's y. So K has an x value of 3 and a y value of 7. So that's x, that's y. So that is your point K. And the point U has an x value of 6 and a y value of 3. X value of 6 and a y value of 3. So that's your point U. x6, y3. You can think that, okay, that's how much you go across from the origin, and that's how much you go up. So you start from the origin, go across by 6. So from here, go across by 6, then go up by 3. Go up by 3, and you end up at the location of U. The same with K. Anyhow, our aim is to find this distance KU. Again, we form a right angle triangle, which KU is one part of that, and you got 2 short sides. So basically from U, you draw a horizontal line, from K, you draw a vertical line. Where they meet, it will be right angle automatically, and you will end up with a right angle triangle. So from U, draw a horizontal line, from K, draw a vertical line, and you will get that right angle triangle. Now the shorter side here is again 3 divisions. The other short side is 4. 1, 2, 3, and 4. So 3 and 4. And then ku squared using Pythagoras again. This is squared is equal to the shorter sides squared and added. So 3 squared plus 4 squared, which gives you again 25, and then ku must be 5 units. Apart from that, we can also use a formula to find the distance. This formula is basically the formalized form of what we just discussed. So that formula is d is equal to square root of bracket x2 minus x1 bracket closed squared plus bracket y2 minus y1 closed bracket and squared again. So that will give you the distance. X2 and X1 are the two X values, because we have 2 points. Each of them has got one X value. You put that here. And Y2 and Y1 are the Y values. Again, you have 2 points. Each of them has got a Y value. So you put the Y's here. And then you plug in this formula and put in your calculator, and you find the value of D. Let's look at an example. Find the length of interval of PQ. So this, they could have said that find the distance from P to Q. It is the same thing. If they ask you, find the length of PQ, or if they ask you, find the distance from P to Q. All right, P has got these coordinates, 2 and 5, and Q has got these coordinates, 3 and 8. Remember, the first ones are X values. That's X and that's X. So one of them is X1, one of them is X2. It doesn't matter how you take it. Here I've taken this as X2 and this as X1. So in the formula, then X2, which is bracket, then 3 minus X1. X1 is 2. So 2, bracket close and squared. Plus, now Y2 minus Y1. That is Y2, that's Y1. Again, as I said, doesn't matter which one you take as Y2 or Y1. It will give you the right answer, as long as you don't mix up X and Y's. So remember, the first ones are X's, the second ones are Y's. But which one is X1, X2 doesn't matter. Which one is Y1, Y2 doesn't matter. So plus, that's the difference of Y's, Y2 minus Y1, 8 minus 5 squared, and that should be squared. 8 minus 5 squared. And if you plug that into your calculator, so you get 3 minus 2 squared plus bracket 8 minus 5 squared. As I said, this should have been 2 squared. Then if you plug that all in your calculator, right, you type square root, then bracket 3 minus 2 bracket closed squared plus bracket 8 minus 5, and 8 minus 5 in the bracket again squared, and after typing that you press equal and you get 3.16. So the distance between PQ, or the length of PQ, is 3.16 units. Thank you for your attention.